So 12.6, last geometry lesson for a very long time. When they talk about a locus, okay, 12.6, all about locuses, loci, they're talking about a set of points. Girls, no stories. Hang out with me. When it's plural, it's loci, okay? But a locus, singular, is just a set of points that meet some requirement, okay? So they're going to say all the points that fill in the blank, and then you have to find all the points that fill in that blank. So I'm just going to jump right in and show you how you do that. This first one says in a plane, okay? Now, every time we do in a plane, we are talking two-dimensionally. If they say in space, what do you think we're talking? Three-dimensionally, okay? So in a plane, two-dimensional, they want the set of points that are 1 centimeter from segment CD, okay? Now, this entire lesson, you don't have to measure at all. If it says 1 centimeter, just eyeball it, say, I bet this is about a centimeter. Really, if you just label it correctly, don't measure a thing, okay? We're just gonna give a general view. What matters is that you're consistent in your measurement. So it says all the points 1 centimeter from CD. So if I'm looking at CD and I think, where could I go that I would be 1 centimeter away from CD? Well, I might go up here, okay? And that would be 1 centimeter. But I could also do that over here, and then I would be here. I could also do it down here, right? And that would be 1 centimeter away. Or I could go right here, and that would be 1 centimeter away. So there's a lot of points that are 1 centimeter away from this segment. What would the figure look like that would be all of those points? Okay, a rectangle is a good guess. Let's think about this. If we made, don't write this right now. Oops, I didn't draw that very well. If we made this a rectangle, okay, that means this should be a centimeter, this should be a centimeter. We always go perpendicular when we're talking distance, right? So far we're good with a rectangle. Where we struggle on the rectangle is if I go here versus if I go here. One of those is longer. Okay, more like an oval shape makes more sense, right? I did this poorly. I shouldn't have. Okay, so instead, if I want to go 1 centimeter away everywhere here, I end up with kind of a rounded end, right? Everything 1 centimeter away from a point is going to wrap around that point. So, oh, you guys, this is bad. Okay. Oop, nope. You can leave what you have because you're probably a better drawer than I am. I'm going to rearrange just so that I can give you a good picture. So if I want to go 1 centimeter above, 1 centimeter below, but then wrap around 1 centimeter, you get, pretend my drawing is not great, but if these are all the same distance away, right, 1 centimeter everywhere we go, these are perpendicular, 1 centimeter, 1 centimeter, I would get, I always call it a track, right? It looks kind of like a track for you runners out there. I know we've got a few. You run around the track a lot, don't you? Does that look kind of like a track? Your locus is none of the dotted lines, okay? The locus is the solid line that you see that makes that track, all right? But I want to see the dotted lines, just at least one that shows me what you measured, right? It was 1 centimeter away. Everything was 1 centimeter away. Draw me a dotted line or two, okay?
So we only need one.
One is great, yeah. Okay, so now think about this one. In a plane, so 2-dimensional or 3-dimensional. If it's in a plane, 2-dimensional. In a plane is always 2-dimensional. the set of points 1 centimeter away from point A. What are you going to get? A circle, and your radius is 1. So if I go 1 centimeter away, and I do that in every direction around my point, I will get a circle. Okay, again, my locus is the solid line, not the dotted. My locus is the solid. That's why we don't want to make the radius a solid line. Just keep the solid as your answer. Anything else should be just a dotted line to represent length. The locus is a figure. It's a set of points. So
It's the whole thing.
these are all points, right? But it's so many points right next to each other that it appears as a circle, right? So that solid line, that circle, is your locus. Okay, this one's a little bit different. This one says in a plane, so how many dimensions?
2.
2-dimensional. In a plane, the set of points in the interior of an angle and equidistant from the rays. What does it mean to be equidistant? The same distance. Okay, so interior of the angle. First of all, do you remember where the interior of an angle is? The inside, right? This is the interior. So when it talks about the interior, that's it, okay? That's not part of our locus. I'm just showing you where the interior is, okay? What would be every point equidistant from your 2 rays, from the sides of your angles? Anyone give me a description of that? What would be the set of points that's equidistant from your 2 rays in that pink zone?
A line, a segment.
It will be a line.
Like a line in the center.
Well, it'll be a ray, right? Because to stay in the interior.
So it goes
What kind of ray?
a straight one.
A what? Who said it? A bisector. Right. If I want to be, okay, if I want to be equidistant, like, oops, say this point right here is the same distance to this one as it is to that one, right? Same thing here. Same distance to this one as it is to that one. So those are the same. Those are the same. If I kept going like that, I would end up with an angle bisector, right? So my locus is the angle bisector. It's inside the 2 rays in the interior of the angle, but it's the same distance away from the rays. Okay? All right. This one says in a plane, the set of points equidistant from the endpoints of a segment. Yeah, Audrey.
I was going to ask about the previous one.
Yeah, what's up?
So what was it asking for?
This,
Is it just an
it's asking for the set of points that's inside and equidistant. So your answer is that blue angle bisector.
Okay, so if it came up in the homework, we wouldn't be naming it, it would be drawing it out.
You'll draw it. Yeah, I mean, if it says name it, you can name it. I will make you draw it, like on every, well, you don't have a quiz on this part, but on the test, you'll just draw it for me. Yeah. Okay. The set of points equidistant from the endpoint. So here's your endpoints, right? A point here, a point here. Where is there a point that's equidistant from those 2 points? Right in the middle. So I know there's a point right here, right? Those are the same distance away. Can you find another point that's equidistant from those endpoints?
Right above that.
Right above it, like right here, maybe? Is there another one?
Right below it.
Right below it, right there maybe?
Line through.
And a line going through it. That could be any point, right? So if I draw this line in, any point on that line would be the same distance to both of them, right? I could pick a point down here, and that distance is going to be the same as that distance. So my locus is the purple bisector, right? It's a perpendicular bisector. So this, I'm going to make it red just so it stands out. That's my locus, not the dotted lines, right? Just that perpendicular bisector would be every point that's the same distance away from those two endpoints. Questions on that? Okay, now we get fancy, and I'm gonna color code for you on this because I feel like it makes a lot more sense to see what's going on. Okay, so the stuff that's in red, I'm gonna draw in red. The stuff that's in blue, I'm gonna draw in blue. And when red and blue meet, what do they make? Purple. Your answer is gonna be purple, okay? Because your answer is where these things meet up. Okay, so example 2 here, it says in a plane, the points equidistant from M and N. Now you just did this one. What is everything equidistant from two endpoints? The perpendicular bisector, right? So you would have a line.
Yes.
There's locus on the final, yeah. Right? That red line is your locus for the red descriptor. Okay? Then we go to blue. It says that and, okay, and being the key thing, because you have to meet both of these requirements. And less than or equal to 2 centimeters from the midpoint of MN. Okay, so you got to figure out where's the midpoint of MN. You already found that with your perpendicular bisector. Everything that is less than or equal to 2 centimeters from that midpoint. Now think about that. What do you get with that? To everything, what would be everything? It'd be a circle, okay? Everything 2 centimeters from the point, and we don't have measurements here, so we're just gonna pretend that this is 2 centimeters. Okay? That would be everything 2 centimeters from the midpoint. But this says everything less than or equal to 2 centimeters from the midpoint. So what do you have to do? Fill it in, right? That circle is filled in. Your locus for just the blue would be all of this blue that you see. Okay, now because of this word and, we have to meet both of those requirements. Do you see where your locus truly is? The red line where it overlaps the blue, right? Not the whole thing, but it would be this. Oops. It would be this. That purple segment would be your locus, because that's where the red line met the blue circle. Does that make sense? So you're looking for overlap. When there's 2 requirements, you have to draw both of the requirements and see where do they overlap each other. And that is your answer. Okay? Okay. Look at letter B. It says in a plane, so still 2-dimensional. For the red, the points equidistant from the given lines. What do you get if we want everything that's equidistant from those lines? It's an angle bisector essentially on every angle, right? So it's going to go here and here, but it's also going to go here and here. Okay, so that's our red. It's basically an angle bisector at every angle you see. Okay, the other part says, and everything 2 centimeters away from their intersection. So their intersection is here, right? What would be everything 2 centimeters away from that little green-blue point? A circle. So again, 2 centimeters away, we're just eyeballing, we're picking a random, that's not awesome. Okay? But that's not your answer. What's your answer?
The line that goes.
4 points.
The lines that make the X and connect to the green.
Not the lines though, just the points,
Yeah.
right? So where red meets blue, and where red meets blue, and where red meets blue, and where red meets blue. So your locus is those 4 purple points.
How come in the other one it was
Okay.
like a line?
Because of this. Less than or equal to means we had to shade that circle in, right? This just says everything 2 centimeters away, so we don't shade it in then. Questions on that? Okay. Last thing. These ones you'll notice, they all stay in space. All you need to do when you think in space is think 3-dimensionally. Here's what I say. Start with it 2-dimensionally and then make it pop, okay? So it can be a 2-dimensional drawing initially, but then you need to turn it into a 3-dimensional because usually the 2-dimensional is a little easier to visualize and then you can draw it as 3-dimensional from there. So in space, the set of points 3 centimeters away from point A. What would that be 2-dimensionally? 2 centimeters, 3 centimeters away from A. What do you get? A circle. What is a 3-dimensional version of a circle?
Sphere.
A sphere. So you have to draw a sphere, which means just draw a circle. That's not my best work. Where this is 3 centimeters. But then to make it a sphere, you draw the great circle. You draw that. Oh, guys, that is not pretty. Hopefully you draw a prettier circle. I should just use an actual circle, huh? Well, whatever. I'm not going to. You know what I mean, right? Okay, so that's the first one. Questions on that? Okay, the second one. Again, it says in space, so you still need to talk 3-dimensionally here. The set of points 2 centimeters away from a segment. So if we're doing, put your phones away. If we're doing a 2-dimensional picture of this, what is it going to look like? Not a line, because it's not away from the end points. It's away from the whole segment. That's the track, right? Okay. A 3-dimensional track.
An oval sphere.
An oval sphere. I always call it a pill. You know those pills that have like the 2 pieces that you would hook together? They're like the capsules. So you can start with it as your little track. Okay, but then to make it 3-dimensional, basically you're taking a cylinder with a half a sphere on the end of it, right? So like this, and it kind of looks like a pill, okay? This would be 2 centimeters away, but it's also 2 centimeters that way. Okay, so on every side, in space, so 3-dimensionally, 2 centimeters. Did a lot of 2 centimeters today. Okay, last one. Think about this one for me. In space, so 3-dimensionally, the set of points 2 centimeters away from a line. How is this different than 2 centimeters away from a segment?
Because the line goes on forever.
A line goes on forever. So where do you wrap around the edges?
Never.
You don't. So what is this? It is a never-ending tube, right? It is a cylinder that goes on and on and on. Now, that's not drawable. So we just draw it as a cylinder, which is fine. So essentially you have 2 centimeters above, 2 centimeters below, and then just round off your edges and make it a cylinder. And we call that good. So this is 2 centimeters or 2 centimeters. Okay. It would keep going forever, but there's just no way to draw that. So we just leave it as a cylinder. Questions on that? Okay. that's the general idea. There's going to be a whole lot of more options. You just can't give you every option that you're going to see in the homework because there's just too many of them. So you need to stop and think about, how do I meet these requirements? This is my son.
Mom, I threw up.
Hi, you're in my class right now.
Oh, you are?
Yeah, how are you?
Not really.
That's okay. Are you not feeling good?
No.
No? Okay.
I never did take the medicine, but
You haven't taken the medicine? Yeah, you should. Tell me about your symptoms. Do you just have a headache?
probably gonna have
Okay. Do you want me to come home?